Okay, welcome back to the AutoCAD lecture series. Today we are going to see a topic is called relative polar coordinate method. So before going to understand about relative polar coordinate method, first we will see. So these are the angles AutoCAD will consider when we are drawing diagrams. Okay, you see, this is a positive x direction. When you are moving in the positive x direction, this is the AutoCAD will be considered as a 0 degrees, and you are moving in the positive y direction or y axis. AutoCAD is considered as a 90 degrees. And similarly, when you are moving negative x direction, AutoCAD will be treated as it is a 180 degrees. And similarly, when we are in the negative y direction, AutoCAD will treat it is a 270 degrees. Okay. So why we learn this one, we will see within few minutes. Okay. So in relative polar coordinate system, if you see what is by relative, we already known relative in AutoCAD. We mentioned relative with respect to at the rate, and polar in the AutoCAD it was represented with the less than symbol. You can see I will be repeating once again. In AutoCAD, relative was indicated with respect to at the rate symbol, and polar was represented with a less than symbol in the AutoCAD. We will see just now. So here we have a diagram where this is our origin. We have 0 comma 0, and we have another point P1. So if you see P1 is at a distance of 20 mm along the x direction and 20 mm along the y direction. So definitely P1 coordinates can be represented as a 20 comma 20. So when you are representing the first point in the AutoCAD, always it is a absolute method. That is, it was taken from the origin. The P1 was represented or written with respect to origin only. So that is 20 comma 20. After representing P1, so when you are moved to P2, so P2 represented with respect to the previous point, which is P1. I will be repeating once again. P2 is represented with respect to P1, not to the origin. So if I write P2 coordinates, I already said it is a relative polar coordinate method. So that means here we will be representing relative, which is at the rate, the distance between the P2 to P1 is 80. And the polar will be represented with a less than symbol. So here we try to know the angle here. If I see this diagram, P1, when you are at P1, we are moving towards P2. Okay, you can see we are at P1, we are moving towards P2. If I represent this one in this diagram, you can see I will be considering always the starting point or initial point at the center. If I consider it is P1, I will be moving in this direction. You see, this is your P2. Try to understand here. So always starting point was represented at the center, and the point will be represented onto this angle. So now P1, P2, we are moving. So the angle is 0 degrees. So we'll be representing the angle at here, it is 0 degrees. So this is how we can represent P2 coordinates in the relative polar coordinate method. And similarly, if I write for the P3, I see P3. So P3 was represented with respect to P2 because it is relative. So I'll be representing at the rate at the distance. You can see the distance P3 to P2 is 30. Now at the rate 30, and if I represent P2 to P3 at here, I see if I represent, I already said starting point is a P2 because we'll be writing for P2, and P3 if I see P3 will be at here. So that means we are moving from P2 to P3 along the 90 degrees. So we'll be writing the angle is less than 90 degrees. And similarly, if I write for P3 to P4, so will be the distance between P3 to P4 is 10. You can see the distance between P3 to P4 is 10. I will be writing at the rate 10. If I see 180 degrees, that means P3 to P4, we are moving negative x direction. Definitely the angle is a 180 degrees. And after that, we will be moving from P4 to P5. If I see, we will be try to move from P4 to P5. If we see the P4 to P5, the direct distance is 15. So I'll be writing P5 as at the rate 15. If I see the angle, here you can see angle it was represented from the 0 degrees. That is 0 degrees. We are initiating from the 0 degrees. The angle at here it is 108 degrees. So I'll be representing less than 108 degrees. Then now we are at P5. Now we are moving from P5 to P6. So the distance between P5 to P6 is 10, and we are moving in the negative x-axis. The angle is a less than 180 degrees. After P6, we are moving from P6 to P7. If I see P6 to P7, the distance is 15. So at the rate 15 less than, you can see the angle was already given at here. From here to here, you can see from the positive x-axis will be considering our angle. The angle here P6 to P7 is given 252. So that was represented at here. Okay. Then after that, we are moving from P7 to P8. When you are moving from P7 to P8, if I see the distance between these two, which is 20, I will be representing at the rate 20 less than. We are moving in the negative x direction. So definitely angle is less than 180 degrees. And after that, we are moving from P8 to P9. The distance between these two is 14.27. At the rate 14.27 angle, we are moving in the upward direction, which is positive y-axis. The angle is 90 degrees. And P9 to P10, if I see the distance is 20, so at the rate 20, the angle from here to here it is 180 degrees. And P11, the distance between P10 to P11 again 14.27, and we are moving in the downward direction negative y axis. The angle is a 270, and we are moving from P11 to P12. The distance between these two is 10.73, and the angle between these two, sorry, angle along in this direction is 180 degrees. So this is how we can represent the coordinates in the relative polar coordinate method. Okay, the same thing we try to represent in the AutoCAD. So we'll be using AutoCAD 2013 version. The first step at here, we will be using our units. When I type units, it is asking to select uh, op it is asking to select units. I have a different options here. I will be selecting millimeters, then OK. Then I will be having command is limits, because I need to fix the my diagram within the rectangle box. So this is the diagram. I try to fix this diagram within a rectangle box. So such that I will be constructing a rectangle box here. So I'll be using the lower limit. It is 0, comma 0. The upper limit I will be using 120, comma 90. Okay, we already seen previous videos where I explained in detail about the considering lower limit and upper limit. So I'll be using the lower left corner is 0, comma 0. Enter. Then it is asking upper right corner, which is 120, comma 90. Now, so this is how we fix our limits. Later we try to draw rectangle. When I type rectangle, you can see it is asking first corner point. Already shown here. So we drawn the rectangle as a border for our diagram. So this is our rectangle lower left limit. It is our upper right limit. So I'll be mentioning these values. So it is asking first corner point, which is 0, comma 0. Then it is asking other corner point, which is 120, comma 90. Then you can see rectangle was created, but it is not in our view. So for that, we will be using a command is called zoom, then all. You can see a rectangle will be uh, came to your view window. The next step will be using a command is line. So if you see the previous video, we are using a line command to construct or to draw our diagram. Will be it is asking first point. If I see for this diagram, the first point is P1. So P1 coordinates are 20, comma 20. If I mention coordinates are 20, comma 20, then it is started a line and it is asking next point. Next point, if I see here, P2 already mentioned, P2 is at the rate 80 less than 0 degrees. So the other point is at the rate 80 less than 0 degrees, enter. Now you can see a line was, horizontal line was drawn at here. It is asking next point. If I see next point, which is nothing but P3. P3 is having a coordinate 30 at the rate 30 less than 90 degrees. I will be mentioning the other point at the rate 30 less than 90 degrees. You can see we have a P3 point. Next we have P4 point. P4 we have the distance between P3 to P4. If you see the diagram, we have a 10. So the at the rate 10 less than 180 degrees. At the rate 10 less than 180 degrees. You can see we are simply using at the rate, the distance and the angle. Next we try to construct P5. So P P5 we have, you can see the P5 is at a distance of 15 from the P4 and at an angle of 108 degrees. If I write the value at here at the rate 15 less than 1, sorry, 108 degrees. You can see inclined line was constructed. Next, if I see P6, P5 to P6 is 10 and angle is less than 180 degrees. I will be using a value here at the rate 10 less than 180 degrees. You can see horizontal line was constructed. Next, if I see P7, P7 is at the rate 15 less than 252. At the rate 15 less than 252. Enter. You can see a downward inclined line was constructed. Next, we'll be having P8. P8 will be drawing. The distance is 20 less than 180 degrees. At the rate 20 less than 180 degrees. Then after that we'll have a P9. P9, the value is 14.27 less than 90 degrees. At the rate 14.27 less than 90 degrees because we are moving upward direction. Then next point we have P10, which is 20 at the rate 20 less than 180 degrees. We'll be having at the rate 20 less than 180 degrees. Next, we'll try to move in the downward direction, that is P11. So it is at a distance of 14.27 less than 270. So it is 14.27 less than 270. Now we try to move to P12. P12 is at the rate 10.27 73 less than 180 degrees, which is at the rate 10.73 less than, sorry, 10.73 less than 180 degrees. Now we will simply type close such that our diagram will be completed. So this is how we can draw relative polar coordinate method. If you see the diagram, it was same replicated which was shown at here. Thank you. Thank you very much.